So last time we did 2013 structured essay until the last part. 2014, right? Yeah, 2014, 11, 12, 13 we have done. 14 structured essay question number 1, the last part we have discussed. We discuss about the resonance structures, and yeah, I'll share the screen. You can see the screen now. This is 2000, yeah, this one. 2014. I think part 4 onwards we have discussed, right? Right. Okay, let's see. Here is the Lewis structure. So first I'll draw the Lewis structure of the most stable one. I don't know whether you can remember this now. It's based on the most stable Lewis structure. Yeah. I'll quickly draw the Lewis structure. Then after that we'll decide the bond angles. Now there are two things. Now this type of it's difficult to post the answer to the chat. You can share your screen. You can take a you can share your screen and take a photograph of your answer and share. I can give sharing, or else you can annotate on my screen. You can write the answer if it's possible. I don't know whether it's comfortable with the mouse. So this is nitrogen, and there's a triple bond, carbon, then N, yeah, N, triple bond, carbon, again nitrogen, then you have carbon, then you have NH2, and here again you have NH2 group. So here you have a lone pair, and here you have a lone pair, right? And here you have a lone pair, and here you have a lone pair. This is what we have done under part 1, the most stable Lewis structure for this, and there's a double bond here. Right. So this one we have already discussed. Now we have to sketch the shape of the molecule with approximate bond angles. Right. All the bond angles other than NH bonds. Now you can see this around the triple bond is linear. Around the triple bond is linear, right? Because sp hybridization. So these three atoms should be in the same line. That is one thing. If you can mark with a pencil, same line. Why? Because sp hybridization. Have you all done hybridization? Done, right? So this is sp hybridization. This carbon atom, sp hybridized. Therefore, both these, this 180 angle. Then all three should be in this. Since it is sp, so this is 180 degrees. Therefore, you draw linear. But this around this nitrogen, I'll highlight that this nitrogen angular. This is bent. This nitrogen is angular because of lone pair, repulsion from the lone pair. So I'll take this nitrogen first and draw. I'll take the nitrogen first. This nitrogen, green one. So then I have to draw it bent, right? So it's like this. It's around 120 bond angle. So we have to keep this angle 120 because it's trigonal plane. Electron pair geometry approximately trigonal plane, this should be around 120. After that, the rest is this side linear because sp hybridized carbon atom, there's a lone pair on this, that's why it's bent or angular. And here you have carbon, and then there's a triple bond, carbon, then you get a triple bond like this, and nitrogen. There will be a lone pair on this. After that, so this is again carbon. Around this now is trigonal plane. This carbon is sp hybridized again, sp2 hybridized. This sp2, sp2. Then you can have NH2 group. But because NH bonds, the bond angle not necessary. Here NH2. NH2. So then you can mark the bond angles. It's 120 here. This one 120. And this one also 120. This also 120. This one approximately 120. This one approximately 180. Between these two. But anyway, it's from 120, if you put 118 or any of the other values also, if you put here 118, because it will not be exactly 120 because lone pair. There will be like, it's like this now. If it is exact, if you take BCl3 like that, if all three bonds are identical, then you can, if all three bonds are identical, then it's symmetrical, then you can put here 120, right? But when there's a lone pair, the lone pair make more repulsion because lone pair and bonding pair, there will be more repulsion from this lone pair. Therefore, this will be less than 120 actually, like less than 120. So therefore, you can mark here 120. It will say 118 accepted. That is that you have to be careful. It should be less than 120. The others 180 to 120 like plus or minus, like I mean this also around 119 accepted. They have accepted the answer within a certain range. No need to become exactly 120 here. So if you put values between like 115, even accepted. But remember, if your Lewis structure is wrong, then this will go wrong. That is a risk here. Imagine if the Lewis structure is wrong, no marks for marking bond angles. That also you have to be very careful. Imagine if this one is wrong, the Lewis structure, no marks for this. That's why this type of question you have to be very careful. If the most acceptable Lewis structure go wrong, everything go wrong. That is the risk of this type of question. Please raise the hand those who got this correct, both of you. Did you get this correct? Right. Sushan, what about translating? And there's one more thing now. The other students are going to Miss Madhu also now. Bit differently. Okay, no problem. Translating. If she's going to start the paper class from January, Miss Madhu Habutantri. because I gave all my theory students to her, because after because I am like little busy. Miss Madhu will be starting the paper class from January. So if you want, you can join with that class also, because other students also are informed. Are you going? You're going, right? Theory class? Were you informed about that? I told her to inform the students about that also, the paper class, because I only told her to start the paper class since. Yeah, okay, okay, right, right. Session, are you planning to join that paper class? Right. If so, then no. Okay. If you are joining, then let me know, because it's easy, because I told her to start the paper class. Right. Okay. Then okay. So do you get me now? What happened? Uh, uh, you have to draw the correct Lewis structure. After that only you can decide the shape and geometry or bond angle and everything. If the most acceptable Lewis structure go wrong, then that is the risk of this structure is a compulsory question. So therefore this one they have accepted within a range, like actually 120 to 115 the range, right? They have accepted, but if you mark 120 they might not allow marks because of the lone pair. One of the best example, if you take water molecule also angular, but the bond angle is not 120 because of repulsion from two lone pairs. So this is around 104.5. So you have learned this, right? And then if you take ammonia NH3, right? Ammonia NH3 around nitrogen, there are 3 sigma bonds. So there's only one lone pair. Therefore, this one the bond angle will be more than 104.5. So therefore, depend on the number of lone pairs, the bond angle changes from the expected value. That's a bit important. Then the next one, so this one you can mark, right? 119, even less than 120 also approximately accepted. 120 plus or minus 2 accepted, right? 120 plus or minus accepted. So therefore if you mark here 120, no problem. It's because no lone pairs, no lone pairs, therefore 120 accepted, but they have accepted that within a range. 120 accepted here, this also 120 accepted, right? No problem. But this one you have to be careful, right? This is 118 because of the lone pair. I told repulsion from the lone pair. Right. That is about this. Anyway, some papers they have asked which atoms lie on the same plane. I mean same line, same line. Which atoms on the same line? If you only can mark that additional information here, this nitrogen and this carbon. I mean these three. I'll highlight that red. These three lie on the same plane. These three lie on the same plane. These three atoms. These three atoms lie on the same plane. Understood? It's on the same plane. And not same line, not same plane, sorry, but same line, but and same plane as well. Same plane and same line, these three atoms. If you take nitrogen, carbon not in the same line but same plane. Right. Then next one, part 5. I'll erase this. Wait, one more thing. They ask here. I'll mark again. This is SP. Okay. The next question based on the hybridization. N1, N2, N3. What is N1 here? Well, again, unless you might have forgotten. I got here 1. This is 1. This is 2. This is 3, no? Yeah. And this is 4. And this is 5. And this is 6. Right. So I'll N1 will be what? What is the hybridization? I think we discussed not N1. I think some of this earlier I'll previous question we discussed this. I think they asked about C2. C2 hybridization SP. This is SP. SP. This N3 will be SP2. This is SP2. Why? Because there are three pairs of electron except the 5 bond. If there are 3 pairs, sigma bonds and lone pairs 3, total 3. That's why SP2. This is only 2 sigma bonds, that's why SP. So this one only 3 sigma bonds because 5 bonds are not considered for the hybridization. Then C4 will be SP2. This is SP2 and N5 and N6 that is SP3 because here also there's a lone pair, no? Yeah, sorry about that. I forgot the lone pair in this one. You have to put the lone pair on this, otherwise no marks in the exam. Here also there's a lone pair. NH2 group has a lone pair. Both NH2, yeah, both this. Then that is again SP3 because 2 sigma bonds and 1 lone pair. This is SP3, N5, and N6 also SP3. N6 also SP3. Can you all see the screen clearly? Okay. Then right. Here's how you get it. Same line. That is because some people they ask which atoms lie on the same line. Now you can complete part 5 easily. With this understanding, you can easily complete part 5. N1 and C2. What are the this is what? This is actually 2p unhybrid orbital. This one 2p unhybrid orbital. 2p unhybrid also accepted. If summarized, SP hybridization also will be accepted. Because mostly hybridization we are interested about the terminal atom. The central atom. Hybridization that's for terminal atom mostly unhybridized, but therefore they have accepted 2p also for this. So therefore I'll write here this 2p atomic orbital, 2p atomic orbital. I put a dot o, atomic orbital a dot o dot for the atomic orbital. Then C2 will be, look at the structure, C2 here sp, no, sp hybridized orbital, sp hybrid orbital h dot o dot. Then C2 again, C2 sp hybrid orbital, and N3 will be sp2 hybridized orbital. Because no need to explain, no, I have already marked here, right? Okay, answer only correct, good. Then N3 it is sp2 hybridized orbital, and C4 sp2 hybridized orbital. So actually this one if you, what happens now if your Lewis structure wrong, what everything wrong, no, part 4 and 5 also will go wrong, even part 3 will go wrong. Therefore you have to most critical one here, the most acceptable Lewis structure, remember that, because after that the resonance structures, if they ask you to draw the resonance structures, if one go wrong, no problem, because you lose marks only for that part. Remember that all the other parts, the answers depend on the most acceptable Lewis structure. Okay. So you should better I mean in the exam you have to double check before you write the answers for the other parts whether your most acceptable Lewis structure, most stable Lewis structure, whether it's perfectly done or not. Otherwise you will lose marks for the other parts. Right. Then I'll erase the screen. Shall I erase the screen? Any question about this hybridization and bond angles? Okay. I'll erase the screen. The next one, part C. Part C. Consider the two chemical substances CH3Cl and CH3I. So boiling point also they have given. From why boiling point is given? You can have rough idea about 249 Kelvin and 316 Kelvin. Boiling point means volatility or the vaporizability. Higher the boiling point, lower the vaporizability. Because when the CH3 part common to both, now chlorine and iodine, what is the difference? Iodine, that RAM is greater than chlorine, therefore that molecule become definitely heavier. What is the heavier molecule? CH3I. What is the larger molecule? CH3I. It's common sense. Now, how to decide this? The strongest dipole moment depends on the electronegativity difference as well. And the bond length also matters there. There's an equation for the dipole moment. You might have learned that, right, in a theory class. Electronegativity also they have given at the bottom 2.1, 2.5, iodine 2.5, it's chlorine 3.0. So therefore, obviously CH3Cl higher electronegativity difference than Ci. So you can post the answer to the chat for the part 1. Yeah, very good. Both of you are correct. It's CH3Cl. Larger one you get CH3Cl. So that one you can understand. It's not hard, right? No need to explain. Then next one. Which substance has a stronger London dispersion forces? Yes, who can tell me the answer? What is the answer for the part 2? Which one has stronger London forces? Stronger London dispersion forces. Yes? Answer is CH3I. Why the CH3I? Iodine has large electron cloud than chlorine. Write the reason why London dispersion force is greater in CH3I. Because iodine is larger than chlorine. When the molecule become larger, the London dispersion forces also become stronger. CH3I will be the answer. CH3I will be the answer. What is this one? Right? You can write CCl bond is more polar. Bond is has higher polarity. Higher polarity of CCl bond. That is the reason. Just write down within the reason. They not ask the reason. Higher polarity of CCl bond. Higher polarity of carbon chlorine bond. This one iodine is larger. Iodine is larger. Large electron cloud than chlorine. That's why London forces become more stronger when the molecule become larger. Good, but yeah, that's correct. Next one. Part 3. Okay, part 3 also you gave the answer. John, what is the answer for the part 3? Has stronger total intermolecular attractive forces. Total. Stronger London forces plus stronger total. That also CH3I. That also CH3I. What are the two factors that affect for this CH3I? Total, both dipole and London forces both will affect CH3I. Because right here stronger total interval by attractive forces, size of the molecule as well as polarity both will affect. So here size of the molecule is more dominant, predominant, like more significant than the polarity. What type of intermolecular force is dominant in comparing this? Which one is dominant? So it's polar dipole interaction or London dispersion forces. Actually, why the answer for part 3 becomes CH3I? What are the other terms used for the London forces? Dispersion forces. London dispersion forces, sometimes we call it London. What is the other term? Induced dipole or instance dipole. Induced dipole interaction. So the reason is London dispersion force. So just write London force, that also accepted in the exam. Or you can write induced dipole, induced dipole. Induced dipole. Is that clear? Okay. How many parts correct out of these four? How many parts correct? 3 out of 4. Okay, good. Understood? Okay, very good. Okay. Right, very good. All correct. Right. Nishan got all, only 3 correct. Right, I'll erase the screen now. Then next one, 2015 paper. 2015. I've done part 1. Part 1. Have you all done part 1 also? Or shall I start from part B? Part A. Have you done part A or shall I discuss? Please raise the hand if you have done part A. Are you tried? Run Silodi? You're done? Okay. Right. So then we'll discuss, no? Yeah. Because some of them, most of them, like it's from general chemistry. Right. Therefore, we can discuss that question. Yeah. Okay. Now the first one they ask both ionic and covalent bonds. So very good question. Which one has both? Now sometimes we are talking about this compound is ionic, this compound is covalent. But sometimes remember in the exam there can be ones with both ionic and covalent bonds. But overall the compound is ionic. Overall the compound can be ionic. But ionic compound could contain sometimes covalent bonds also. Ionic, please write that. Sometimes you can get in upcoming paper statement, the statement or ABC type question. An ionic compound can contain covalent bonds. Possible. This is one example. Very good question. Part 1. Yeah, who gave the correct answer now? Yeah, Sejan, you gave the correct answer. Very good. Sodium sulfate. Answer Na2SO4. Which one has both covalent and ionic? Na2SO4. Sodium sulfate. How come? Now remember the sulfate ion SO4 2 minus sulfate, and between Na plus and sulfate ion, that is ionic. Please label that. This is ionic. But if you take only sulfate, it's like this sulfate. Draw the structure of sulfate ion like this. Tetrahedral, no? This is the structure of sulfate ion. Look at the screen. This is the structure of sulfate ion. Right? 2 minus. SO4 2 minus. So sulfur has formed how many bonds here? 6 bonds. So these 6 bonds are what? 6 covalent bonds here. What? 6 covalent bonds. 6 covalent bonds. Can you write that? Please write that. Sulfate ion contain covalent bonds, but Na plus and sulfate ion ionic. That's why it has both ionic and covalent. All the others contain only covalent. All the others contain only covalent bond. I mean so primary interactions I am talking about. Is that clear? Right. Then part 2. Part 2. Let me quickly post the answer to the chapter. Part 2. Isoelectronic with BF3. Isoelectronic with BF3. What is the answer? Yes? Consider. Isoelectronic with BF3. Which one? Hmm? Right, I'll write. Okay, you post the answer. Let's see. Okay, NO3 and answer to give is NO3. Sijan give NO3, SO3, NO3, SO3. Part 2. Yeah, it's NO3 minus actually the answer. How come NO3 minus? How come NO3 minus? Okay, let's see the thinking process for this. NO3 minus will be the answer. Look at the screen, I'll explain. What is the meaning of isoelectronic? Same number of electrons. Right here, what is the meaning of isoelectronic? Having same number of electrons. Same number of electrons. Same number of electrons. Same number of electrons. Right. Now if you take BF3, boron, how many electrons were? 5. Right here, boron 5. Then fluorine 9. 3 fluorine, 3 fluorine, 9 into 3. Total 9 into 3. So then how many electrons total? 9 into 3. So it's 9 into 3. I put 27. 27. 27. Within brackets I write 9 into 3. What is the total? 32. 32. 32. So if you check NO3 minus, let's see NO3 minus, nitrogen how many? 7. Nitrogen has 7. Nitrogen total atomic number 7, 7 electron. Then oxygen, atomic number 8. 3 oxygen. 3 oxygen, you get oxygen 8. 8 into 3, 24. 24, within by side right, 8 into 3. Periodic table is given, don't worry. Periodic table is given, you can check the atomic number of any of this. Then for the negative charge what? Minus 1, plus 1. 1 electron gain, then what is the total? 32. So no need to waste time for the others, you can easily count the total like this. You can easily get the total. So this also 32, this also 32. Isolation means same number of electrons, equal number of electrons. If you only can check the others. Now obviously what happened, this one has 4 oxygen. So it's like, it's 8 into 4 itself 32. No? You can easily omit this, no? Right? Now fluorine what? 9 times 5. Total, you can omit, no? Because it exceeds the total number. It exceeds more than 32. No? Right? Very easy to get it, no? Even SO3, sulfur 16, no? sulfur atom number 16, then that one 8 into 3 24, so it exceeds more than 32. You got it? Yeah. So therefore that's how you can get the answer easily. Then part 3, what is the answer? Shall I read this? Right. Part 3, square pyramidal shape. Which one is square pyramidal shape? Yes. Answer, what is which one square pyramidal shape? Okay, both of you are correct. Very good, excellent. SF5 minus. SF5 minus. Very good. That in order to explain SF5 minus. Actually, this paper this is easy. Remember last few years A-level papers much easier than before 2015. After 2015, inorganic chemistry, organic chemistry, it's not that hard. But physical has become little difficult. Right? Physical chemistry difficult, but inorganic and general not hard. Right? Can understand what is square pyramid means what? 5 bonds and one lone pair, no? 5 bonds and one lone pair like this. Square pyramid. Square pyramid because if you want you can write, so this is equatorial, so this is equatorial, and one is axial and one lone pair. Okay, I'll draw like this one we are not looking at the lone pair here, and here also there's a bond, and I'll draw a dotted line for this one in the same plane, this green one in the same plane like this. Then you can draw all 6 fluorine, 5 fluorine, and you can draw the like this, so this like this, then you get square pyramidal shape, no? Right? Yes. Okay, so this is what? Square pyramidal. Square pyramid. Right. One lone pair and 5 bonds. Square pyramidal. But electron pair geometry, SF5 minus, if there's electron pair geometry, then is octahedral. Right? Electron pair geometry, octahedral. What is octahedral? Electron pair geometry. But molecular geometry is square pyramidal. Molecular geometry is square pyramidal. Molecular geometry is square pyramidal. Right. Then part 5, part 4, what is the answer? Part 4, I'll erase this. Part 4, what is the answer? Has an equal number of bonding and non-bonding electrons in the most stable structure. Equal bonding and non-bonding electrons. Equal bonding and non-bonding electrons. Yes? Which one? Bonding electrons and non-bonding electrons. Part 4. So that you have to think a bit. Yes? Answer is? Seshan give the answer. What is the answer for the part 4? SO3. Part 4 SO3. Okay. If you take xenon, bonding electrons 4, because 2 bonds in xenon here. This one, how many bonding electrons? Bonding electrons will be, I put Be, 4, right? But you can see fluorine itself, one fluorine has 3, no? 6 electron. One fluorine has 6 electrons, then it will become 12. So we have to reject this. So here, so what happened? One oxygen has one oxygen has 3 lone pairs. That means 6 electron. It is 6 electron. But bonding electrons will be, and nitrogen also has. So NO3 minus also, NO3 minus and SO3. That we can go, right? Part 4. NO3 minus, we get SO3. I think one of you gave SO3. That's correct. Yeah. Who gave? You gave SO3 for the part 4, right? Part 4 SO3. Yeah, correct. Part 4 SO3, correct. Seshan, part 4 is not HF. Part 4 HF cannot be accepted. SO3, correct. Let's see. SO3, how to do the structure? Look at the screen. SO3, it looks like this. Draw the structure of SO3. How many lone pairs? Each oxygen has 2 lone pairs. 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 Okay. Each oxygen has 2 lone pairs. So in total, how many now? You get total here electrons in the non-bonding electrons will be 4 into 3, 12. 4 into 3, 12. 4 into 3, 12. Then bonding electrons, 6 bonds. Bonding, I put B. Bonding electrons, 1 bond, 2 electron. 2 into 6, 12. 1 bond, 2 electron. Then non-bonding electrons, bonding electrons 12, non-bonding electrons, each oxygen has, for sulfur no non-bonding electron, each oxygen has 4 non-bonding electrons. 4 into 3, 4 into 3, you get 12. Is that clear? What is the SO3? What is the shape of the molecule? Is trigonal plane, right? Trigonal plane. SO3 trigonal plane. What is the bond angle? 120. Those things also you have to recall. Yeah, so you can comment. And there's one. What is the other alternative answer for this? Can you guess? You can go for one more alternative answer for this. Let's see, NO3 minus, will it match? NO3 minus. If you want to write like this, NO3 minus. So here you get 3 pairs. Here you get 2 pairs. Here you get 3 pairs. Right. So oxygen non-bonding will be, non-bonding electrons will be 2 into non-bonding electrons. Each here you get 1, 2, 3, 4, 5, 6, 7, 8, 9. 2 into 9, no? 18. 18. 18. Bonding electrons 8, no? Bonding electrons 8. Wait, we'll consider this. I put bonding electrons. I think that also we can take. NO3 minus. Bonding electrons will be 8. 8. That NO3 minus we can't take, no? Non-bonding electrons more than that, yeah. Because it's 16, yeah. You can't take electrons. There are 16 bonding electrons. Non-bonding electrons are 16 here. That's why. So therefore NO3 minus we can't take. Now if you can find the total number of bonding and non-bonding electrons like this, then that's all right. But if you need to practice more, tell me that I'll draw the others also. Like this waste of time doing this for all the other answers. But if you don't know how to draw the structure around this also, if you don't know how to the structure, then you are in trouble, right? You can't decide any of this. Right. Okay, part 5. Run student, what is the answer for part 5? Sishan gave the answer. Part 5, what is left now? Sigma bond as a result of low overlap for 1s atomic orbital and 2p atomic orbital. That is HF. So anyway, 1s atomic orbital only in hydrogen. That's very tricky, no? Tricky question. You can easily get the answer. What? 1s they are only in sigma bond is formed by using 1s atomic orbital. 1s atomic orbital involved in what? Hydrogen. Put an arrow towards 1s right here. 1s atomic orbital is in H atom, hydrogen atom. Hydrogen atom. Right. Okay. Yeah, answer is correct. Very good. HF. None of the others. Hydrogen is involved in none of the others. It's a very easy question. HF. So this is 2p unhybrid orbital. This is 1s atomic orbital, linear overlap or head-to-head overlap. Sigma bond. It's a polar covalent bond and it's a sigma bond. Okay. So how many of this correct out of 5? How many of this correct? How many of this correct? There's one more part. No, part 6 also. Yeah. Sorry. This one more part is there. Part 6. I'll move down. Part 6, what is there? So can you tell me the answer for the part 6? Content bond angle 180. That means which molecule is linear? Linear will be what? Out of this, which one is linear? XCF2. Which one is linear? XCF2. Part 6, XCF2. How come? Why XCF2 linear? 2 sigma bonds and 3 lone pairs. 3 lone pairs. Let me show you the shape of this. Yeah, very good. XCF2. Both of you are correct. Right. So the last part, the answer is XCF2. Now you can have an idea, even though you write, even the school or theory class, even you write long paragraph, right? Like, paragraph, the explanation. This is how you get questions in the A-level paper from this part, XCF2. Xenon 8, there are 3 lone pairs here. There are 3 lone pairs. So it will be 1 lone pair here and the other lone pair here, and this is 1 lone pair. But actually, if you take here, what is the molecular geometry? Okay, who can tell the molecular geometry? Electron pair geometry of XCF2. What is the electron pair geometry of XCF2? Molecular geometry linear. Well, electron pair geometry, there are 5 electron pairs. 5 electron pairs. When there are 5 pairs, what is the geometry? Angular? No. What is the electron pair geometry of XCF2? Molecular geometry linear. Please write it, because you don't get the same question as it is. That's why I'm asking some additional questions, because in upcoming papers you can get such question. Octahedral means there must be 6 pairs, no electron pairs. To become octahedral there must be 6 electrons, but here only not 5 electron pairs. 2 fluorine donate 2 electrons and xenon 8. Xenon 8 plus 2 10. 10. Then the pairs will be 2, 10 divided by 2, 5 pairs here, 5 pairs of electron, 5 pairs, 5 pairs. But if you are just telling pyramidal, it's wrong. Now only you are putting the answer right. Okay. Trigonal bipyramidal. What is that? Electron geometry. Trigonal bipyramidal. Don't just pyramidal. No marks in the exam. So please write those things. XCF2 linear. XCF2 linear. XCF2 linear. Okay. Then let's see the other question. Give me a second. Okay. Okay, so I got an urgent call. Now, okay, now tell me how many of this correct out of 6? How many parts got you got? Out of 6, how many correct? Out of 6 blanks. All 6 correct? Without referring the note, without looking at the marking scheme, if you had done it alone, without any help, tell me how many correct? Runs in all 6. Very good. Okay, both of you. Okay, 5 out of 6 session. Right. Good. Now when you, this is what I now until your A level exam, what you should do, say now we are doing general chemistry, right? General chemistry. What is the target question? Structured essay question number 1. That is the most important one. Compulsory question is structured essay question number 1 is from general chemistry. Like that. Say example, after doing unit 4 behavior of gases, after doing unit 5, you should know which area of the paper, which section, which part of the paper you are getting question from unit 5, and whether it's given in all syllabus and new syllabus both, or whether the position of the question whether it's changed, those things please update. So one example I'll give you. Before 2011, that means until 2010, this structure is a question number 1, not like this, is different. From 2011 onwards, every year A level structure is a question number 1 like this, right? Like this, like resonance structures, and from general chemistry. Actually, calculation part also not much. from unit 1 and 2, from unit 1 and 2. So like that you should have this idea before I mean after completing every lesson, right? Each lesson, each chapter, each unit, you should know which part of the paper I'm getting question from this unit and from which year I should practice the papers. The teachers, they don't know that. Now if you ask, so this unit from which year should I do the question, and old syllabus which question, so like that you should know whether it's essay type or whether it's structured essay. If it is structured essay, where do you get this? If it is MCQ, how many MCQs approximately, right? So chemical calculation, only chemical calculation, you are not getting questions. That's why that is the problem now. The students, they find it difficult. Chemical calculation, they are doing only chemical calculation, but chemical calculation, only chemical calculation, you don't get questions, maybe one MCQ. So it's it's like a supportive lesson for the other lessons, the chemical calculation. Physical chemistry you can't do without chemical calculation. Inorganic, some parts you can't do without chemical calculation, you can't answer the questions, right? Therefore only, but this one you are getting directly questions. If you do this, if you practice even not only chemistry, even the other subjects, if you after completing every lesson, you should practice last 30 years papers. That itself make, I mean, lot of confidence before facing the A-level paper. At least last 30 years paper. After that you can do that paper, that theory class paper, this class paper, or that I mean your school term test papers or whatever, you can practice the other, but at least past papers, no one can argue because like kind of the standard questions. But if you take a school term test paper, some schools the question is wrong. I'll give one example. I don't tell the name of the school sometimes, but they make the paper singular medium and translate to English. Translation, there are some data missing. Some data missing. Then whatever. How many times you try that question, you can't answer because you don't get the expected answer because the question is wrong or the translation wrong or some data missing. So then what happened, they tell the school, the papers are really standard, no one can do it because the question is so hard and the students are wasting their time. That also there. That's why I thought of doing the first round. I will do all the A-level papers, each chapter, all the A-level questions, essays, and MCQs, right? All three types. So once you complete unit 4 theory, then we'll do unit 4 MCQs in the last 30 years papers, unit 4 structured essays, and unit 4 essay type if they have asked. So unit 4 they ask from all three areas, but this one, the essay type questions, they don't ask this section, very rare, mostly structured essay like that. MCQs they can ask, MCQs they can ask, right? Then we finish this, okay. Then next one, part B. Part B, actually it's kind of little difficult with compared to the ones because they are not given the real symbol of the element. Please raise the hand if you have done it. Run Suddenly, did you do this? Okay, Run Suddenly, have you done it or have you tried this or not done? No difficult, no? Yes, you have done. Right. Then okay, that. Can you, is there any possibility of sharing your screen? Okay, I'll write the structure first. Identify, okay, based on the information. They have a long paragraph. See, there are more than 50 words in the question. There are more than 50 words in the question, but now the answer is just one letter, no? Like the part one. Okay, answer, no problem. Okay, no problem. Right. Now, what is Q here? Okay, how to get? Okay, I'll highlight these three. Q, then R, then T. Others no. So these are the three unknown ones. Now you can easily guess this from the data given. It shows acidic properties. It shows acidic property. That means there must be a OH group. Please highlight the word acidic properties. Acids contain OH group. Somebody will say, how come OH? Bases also have an OH? No. All the acids, okay, if you take sulfuric acid, nitric acid, there's a OH group. H2SO4, it like this. H2SO4 is like this. There's a OH group. Like this. Here. This is H2SO4. This is a OH group. So the bond breaking occurs from which one? I'll draw a line here. Look at the screen. You can learn a lot of things from this. This bond is broken down. Here this OH bond is broken down. Why? OH bond polarity is greater than SO bond. OH is more polar than SO. If bond breaking occurs from here, what happens? Then it will act as a base. It will act as a base. If SO bond is broken down, if this pair break, then OH will be released. Then OH minus, then act as a base. Therefore, that OH is there. Then it loses H minus to form anion. When dissolved in water, the Marx has a Lewis structure. This has negative charge on the oxygen atom. There are no charges on the other atoms. There's minus charge on oxygen. One of these oxygen will carry minus charge. You can select that any of these become minus. No problem, because there's a minus charge. I'll put this one minus charge on oxygen. That when there's a minus charge on oxygen, there are three lone pairs. Whenever the oxygen carries minus charge, there are three lone pairs. That you can. It's a short method to remember. If there are no, that means if there are no minus charge on oxygen, then there's a double bond. Look at here. What are the three methods where the oxygen can be linked to a central atom? Oxygen can connect with a double bond. That is the most acceptable one, most stable one. Oxygen can link with a single bond. Then there's a minus charge on oxygen. And the other one, oxygen can link. Minus charge. Those are the two possibilities. Sometimes oxygen can have three bonds. That is the most unstable one. Most unstable one. Then there will be a plus charge. So oxygen can form three bonds, but that is highly unstable. Mostly more stable with double bond, if not with single bond. Triple bond and more others are highly unstable. Right. Now you can have an idea what is this T now. What is element A? It has formed 6 bonds. Therefore, T should belong to group 6. Can you understand that? T should belongs to group 6. Group 6. Group 6 can oxygen form 6 bonds? Can't. Oxygen cannot have expanded octet. Therefore, T you can have an idea. It should be what? Group 6 sulfur. T. Okay. Then let's see the rest. QRT are nonmetals. Electronegativity greater than 2. Electronegativity greater than 2, that's from carbon, nitrogen, oxygen. Carbon 2.5, nitrogen 3 and oxygen 3.5. Because greater than, and they are nonmetals. All three are nonmetals. The others you can't take. Hydrogen also you can take, but hydrogen will never become. Q and R belong to the same period. Q and R. And T belongs to the third period. That we got in the third period is alpha third period. Then the other most important thing, this one has formed only 2 sigma bonds, Q. R form 3 sigma bonds. That means like valency 3, because Q form 2 bonds. That means this should be under valency 2. Valency 2 means either group 6 or group 2. This should be either group 3 or group 5. They are non-metals. Group 3 you can't take. Group 3 you can't take because since it is non-metal R, either group 3 or group 5. Therefore, R should be from group 5 and it's same period. Because since electronegativity is greater than 2, this should be period 2, second period elements, and they are non-metals. Can you post the answer to that? Yeah, I think very good. Yeah, run session give Q oxygen, R carbon, and R carbon, and T sulfur, T phosphorus. T can't be phosphorus because it should be group 5. No, yeah. Run Siluni, what is the answer? Q nitrogen, R carbon, T sulfur. Both of you, okay, Q oxygen and the other one Q nitrogen. Can nitrogen form only 2 bonds? Nitrogen form 3 bonds. Nitrogen with 2 bonds unstable, highly unstable. Q nitrogen not possible. Can you try again? Run Siluni. Q can't be nitrogen. Q valency 2 only form only 2 sigma bonds. With carbon double bond, I thought it's a double from carbon to Q. Carbon to Q. If that form a double bond, then R there are 5 bonds. Why can't R can't be carbon transfer? Because if you put a double bond with like this, okay, look at transfer. If it is a double bond, then around R there are 5 bonds. Can carbon form 5 bonds? No, wait. That's double bond. And then it make 4 bonds. Wait. 4 bonds. There are carbon. R carbon, Q, you took oxygen. R carbon, Q oxygen. COH, alcohol. COH. Okay. What you thought can be accepted, that also, but R carbon, Q oxygen. T third period. H3O3. H3O3. Now the problem is look at transfer. That is, this is the problem. What your argument is correct, but the problem is at the beginning they have given H3O3 QRT acidic properties. There are no charges on there. Because it can't be again oxygen, then again there will be a problem with this oxygen. Q oxygen, okay. R carbon is the problem. T sulfur, no problem, we have predicted. Q oxygen. What about session? Q, did you predict session?
Sir, I'm saying Q is oxygen, R is carbon, sir.
Yeah, both of you are saying R is carbon, no? Yeah. Right. R carbon. R carbon. Let's see, let's draw the structure and see now. C, H. If you draw here H, H, O, C, again here H, T. Draw this side. H, O, C, H, then you get S, double bond, oxygen, double bond, oxygen, single bond, O, it's a minus charge. And here there will be a lone pair, here there will be a lone pair, and here there are 3 lone pairs, here there are 3 lone pairs, here there are 2 lone pairs, and this one you put, when you put a double, 2, 3, you put a double bond here, what's the problem now? Do you see a problem with this? Both of you told this this is carbon. Now I have a problem with that. That's the only problem I have. This is when you make a double bond here. Okay, I'll draw that additional bond with a different color. This one well, this is a double bond to make 4 bonds. That will be a problem. Why? Can you tell me why? If you put a double bond, what is the problem now? Oxygen, there's a problem. What is the problem with oxygen? Oxygen carries plus charge. That is unstable. Then you can't put 2 lone pairs on oxygen. Oxygen form now 3 bonds. And with a lone pair and plus charge you have to put. Lone pair and plus charge. 3 plus 2, 5 plus charge you have to put. Do you understand what I'm saying now? Then oxygen will be positive. Expanded octet for oxygen, not possible. You cannot have expanded octet. Yeah, that's the problem. Yeah, absolutely correct. You cannot have expanded octet plus you cannot have the other problem is you cannot have a plus charge because then it's unstable. Because they are telling, can you look highlight with the highlight in the screen? No charges on the other atoms. See the way they have filled. It's a nice question. No charges on the other atoms. Highlight that. Negative charge on oxygen atom. Negative charge on oxygen atom. No charges on the other atoms. Highlight that. Underline. I'll highlight and underline both this. Very important. Now okay. Can you suggest? Now we can't put this. What is the other possible? This instead of carbon now we have to replace with suitable one. You cannot have a double bond here. Understood now, both of you? You can put the plus charge under. Sometimes you can argue, sir, can't we draw with the plus charge? Can, but the problem is they are going no charges on the other atoms. What should be the most suitable one for this? Yeah, Seshan, very good. Yeah, runs iluni. Okay, very good. Now excellent. Now you understood ne? Because I wanted to get the answer from you, right? This I didn't write because I wrote what you told, and then you only found the, so that will be what? Nitrogen. Then you will, there will be a lone pair on this nitrogen. Okay, sorry about that. Can you hear me? Because there was a small problem with the internet connection. Yeah, right. Can you hear me clearly now? Okay. I couldn't read because so, right. I'll share the screen again. Okay. So the most acceptable structure you understood, right? Okay. Now let's see. Draw 6 resonance structures for this anion. Draw 6 resonance structures for this anion, and then there's electron pair geometry, shape around the atom, hybridization of the atom, approximate angle of the atom. 4, 1, 2, 3, 4, 4. Yeah. Shape hybridization and electron pair geometry. Yeah. Electron pair geometry. Okay, QRT. Yeah. How many resonance structures were you able to? They're asking 6 resonance structures. So the one that you have done also can be accepted. No? In the marking scheme, they have given 8 marks for the correct Lewis structure and 2 marks for each. Okay, so this one they have given 2 marks for writing here oxygen, and here nitrogen, and here sulfur. So 2 marks each. And this one they have given 8 marks. 8 marks for the correct Lewis structure. Now let's draw the resonance structures. I will use a separate white background for this. Look at the screen now. This is the correct resonance structure. So this is what we got. I'll draw it again. Number 1, first Lewis structure. Anyone can you if you want you can share your screen if you have done it because you can't put this to the chat the answer, because either you have to share that as a file, you can't just type it. If you want you can try. So this is sulfur, double bond oxygen, double bond oxygen, and single bond oxygen. That's the minus charge. Right. Here's what we got, right? Now, how to draw 6 other resonance structures for this? So you have to put the double-headed arrow when you're drawing the resonance. One method, you can rotate this double bond. You can rotate this double bond. Now look at here. Now you can have the double bond in the other two, in these two oxygen and sulfur. So there are 3 oxygen. Now the double bond in this one and this. So I'll put here sulfur, here oxygen and here oxygen. So you can have the double bond. I won't draw it complete because I'll just teach you the method. You can rotate this double bond. There's a minus charge in this. Minus charge here. You can have the rest is same, no change the others. So here you can have the double bond here and here. And make the upper oxygen atom. That is one method. The rest is same, The rest is same. Then the other one, the rest is same, Then you can have the double bond. Okay, I'll highlight them. Instead of double bond in these two, you can have the double bond here and here. The other option, you can have the double bond upper oxygen and axial, like vertically. You make the double bond here and here double bond, and you make this side single bond O minus. That is the other one. Is that clear? This way you can have it. Here with the lone pairs. Lone pairs, if you miss lone pairs, all the atoms of the lone pairs you have to indicate, otherwise no marks in the exam if you miss one lone pair. That is one. So here we make the double bond. Double bond you can change around among these 3 oxygen atom. Double bond. So now how many structures now? We got 3 structures. Now we got 3 resonance structures. What are the other possibilities? Now let's see the other possibilities. You can have triple bond with oxygen. You can have, now anyway around sulfur there must be 6 bonds. That's what we should do. Around sulfur maintain 6 bonds. That's the requirement. Now this is one method of making 6 bonds around sulfur. What is the other method? Any other method? You can do like this. Sulfur you can have 6 bonds. This side triple bond, and the other two single bond. That is also possible. Resonance structures. Most acceptable with structure only the minus charge only on one oxygen. But here this plus, and here minus, and here minus. Is that clear? No point of waste. The rest is same. Rest no change. The others no change. And the next one you can write sulfur triple bond you can have here, and the other two oxygen single bond, like this way. Is that clear? Because oxygen triple bond with the lone pair. Here triple bond with the lone pair, that's a plus charge on oxygen. Then what is the other one? You can have the triple bond. Now it's very easy. Like don't start like your formal method, like it will take long time. Look at in this way the short method. You will have the triple bond this side and make the other two oxygen single bond and with a minus charge. Whenever oxygen connected to the central atom with a single bond, what? Oxygen carries a negative charge. Whenever oxygen is linked to the central atom with a triple bond, oxygen carries plus charge. Please copy down that in a short notebook. What are the possibilities of connecting oxygen to a central atom? Because most of the, more than 90% of the uh, structures that you get in the A-level paper contain oxygen. So then you should have some idea what are the methods of connecting oxygen to the central atom. Most stable arrangement is with double bond. Then oxygen carries two elements. That is number one. Earlier also I told this. I'm repeatedly telling this because it's important. Connecting oxygen with double bond. The other one, connecting oxygen with single bond. Then there will be a minus charge on oxygen. Minus charge on oxygen. Then third method, connecting oxygen with a triple bond. That is highly unstable. Then oxygen carries plus charge and there will be only one lone pair. Please copy down. These are the three methods of connecting oxygen to a cell. And the other method is dative bond. Dative bond. I will write the fourth one. Dative bond. That means oxygen is connected to this one with a dative. Then oxygen carries minus charge and the other atom carries plus charge. Understood? So that is dative bond. These are the three methods. The most accepted, most stable one is this. Then this. And then this. This one is the least stable one with the plus charge. Understood? Any question? Now how many structures did you draw? How many structures? 1, 2, 3, 4, 5, 6. Done. How many structures are they asking us to draw? 6 or 7? 6, no? Yeah, draw 6 resonance structures for this ion. Is that clear now? You can draw many. Like actually the A-level marking scheme, they have given 3, 6, 9, 12, 15, 18 plus 4, 22 structures they have given. Right? 22 structures they have given. 22 structures they have given. You can imagine 22 alternative answers they have got. How come 22? Look at the screen. You can have, there's a lone pair here. Look at the screen, number 1. Look at number 1. There's a lone pair. This lone pair, keeping this side unchanged, you can shift, you can make here double bond, you can make double bond here. Or you can shift from this side. Understood? So that is 1, 2. Like that you can rotate this also. Like that you can have you can have double bond with nitrogen, form double bond with oxygen. That way also you can do it. Keeping this, then the other side also you can rotate. Is there any questions? I mean, do you understand what I'm saying? Now you can make this a double bond. You can make this a double bond and draw the other again one by one. Double bond with this, double bond with this, double bond with this, double bond nitrogen and oxygen double bond with this, double bond, like that you can, for each you can make the double bond with this nitrogen and draw it. Then it will be a different structure. Okay, that's how you can get. They have given more than 20 how many 3 times, yeah, 22 structures. You can draw 22 resonance structures for this, but no point of I think I have that answer here. I took a screenshot of the market scheme. Wait, I'll show. This is the marking scheme answer. Look at the screen. Can you see the screen? This is the marking scheme answer. Can you see here? These ones. This is the marking scheme answer. Here you can see. This is the most acceptable one. Then you can see this is double bond position change. This is the double bond position change. Here you can see again one more here. There was, that is 3 here. 3 of them. Then the dative bond also they have put. Then with triple bond. Okay, no, yeah, no worry. I'll share it to the group. Yeah, sure. Okay, Sijan. And I told you this with triple bond. This is the most easiest one. This triple bond. Here triple bond, here triple bond, and here triple bond. Can you see? So then you can have 6. What are the other methods? You can look at here. You can have double bond here, double bond here, and chain the others. Chain the others. Do you get it? Now this is this way, vertical, and this one, and double bond with nitrogen, no change. Keep in the position that unchanged, then you rotate the other two. Do you understand what I'm saying now? Look at the green one and the pink one. Here, write that. You keep this one constant, this one unchanged. This one I put a right tick. This one you keep unchanged, and you rotate that double bond with oxygen. You rotate. So that way you can get it. Now, in order to draw all this, I don't think they will ever ask it, because to draw this 22 structures with you had put dot dot, then it will take nearly half an hour to draw all these 22. And they will never ask you to draw more than maximum 5, 6, not more than that. Maximum possible 7. Mostly they are 6, not more than that. Even though there are resonance structures more than that, they will never ask you to draw. Now they don't ask all the possible resonance structures. If what happen if they make this question draw all the possible resonance structures, they need to keep 2 pages blank for the space, the answer, right? And the other problem is what? Time consuming. That will be a problem. That's why they have limited here 6, right? But MCQs, there can be a chance of how many possible resonance structures, but this also you can't count until 22, because MCQ also I don't think they'll ask like this. Okay, now let's move to the next part. Okay, I will share that to the screen, or else I will put that to the chat if you want. I'll share to you. I'll share with you separately through the WhatsApp the answers, all these 22. If you want to try this at home, because it is a good exercise. Now let's see the next one. This is based on, right, I'll draw the most acceptable Lewis structure. Again, they don't tell this based on the most acceptable one, but anyway, if your most acceptable Lewis structure go wrong, all this will be wrong. I'll quickly draw it again, then you can quickly refer this and do it. Oxygen, then nitrogen, then sulfur, oxygen. This side you get oxygen, and here minus. Right. H. Look at the screen. This is the most acceptable structure. First one, can you post the answer for the QRT? QRT, what is this QRT? I'll write it with separate color. Can you post the answer for the part 1? This is Q R, because they can't put the real symbol here, because if they put the real symbol here, what happened? You will get the answers, no, for the part 1. QRT, they put QRT. This is QRT. Okay. So hybridization. What is the hybridization? Q it's sp3 because there are 4 pairs, 4 VSC pair. So it's sp3 Q sp3, and R will be again sp3, no? R will be sp3, and S will be T. Also do they ask hybridization? Yes. sp3. 4 sigma bonds, all 3 atoms the same hybridization because there are 4 pairs. This also sp3. T also you get sp3 hybridization. Why sp3? 5 bonds are not considered for the hybridization. What is considered for the hybrid? Please write here. Only lone pairs and sigma bonds are considered for the hybridization. Only sigma bonds total. Sigma bonds and 5 lone pairs. Sigma bonds and lone pairs total matters for the hybridization. Sigma bonds plus lone pairs. I put LP, lone pairs. If sigma bonds plus lone pairs 2, actually it can be 2 0 mostly. It's 2 sigma bonds and 0 lone pairs. Then what is this? Total 2 ne? 2 plus 0 2. Then what is the hybridization? SP. SP. So then the second option, if you can copy down this short note, if you take sigma bonds and lone pairs, it's become 3 here. What is the hybridization? It's sp2. So then there are possibilities. What it can be 3 sigma bonds and 0 lone pairs. Then also is 3. Sometimes it can be 2 and 1 also possible. 2 and 1 also possible. Then also the total is 3. Then also is sp2. Do you understand what I'm saying? Is sp2. One of the best example. SO3 you can take SO3 BF3. SO3 BF3. So total matters here. Total sigma. 5 bonds are not counted. Total sigma bonds and lone pairs matters for this. If it is 2, then is yeah. If total sigma bonds and lone pairs, you get the total. Total if you get 4 here, 4 it becomes sp3. If the total sigma bonds and lone pairs become 4, it's sp3. What are the possibilities for this? It can be 4 0, then also sp3. What are the other possibilities for this? 3 1 possible, 2 2 possible. So here itself you can see ammonia what? NH3 3 sigma bonds and 1 lone pair. If you take H2O 2 sigma bonds and 2 lone pairs. So this is SO4 2 minus. Look at here, SO4 2 minus this one. I'll highlight this 4 0. Here ammonia 3 1, H2O 2 2. So total become 4. Here also total become 4. So in all these what? Hybridization sp3. If you can copy down this, here also sp3. Understood? Right. Okay. Then I'll okay, you have already posted the answer. I'll quickly write the answers for this. Okay. Check with the answers, and if you want, I'll put the marks also. I'll read this. Electron pair geometry on Q, that is tetrahedral. I put tetra here. Tetrahedral. Then the shape will be what? I'll put Q, everything to Q, it's angular. Then Q, hybridization of Q will be sp2. Sorry, sp3. Not sound angle, it should be bond angle. Sorry about that, it's bond angle, BOND. Not just bound, it should be bond angle, BOND. Sorry about that. It should be bond angle. BOND, bond angle. Right? What is the bond angle here? Around, you can write here, if you write 104.5, perfectly correct. If you write even 104 degrees, accepted. Between 103 and 105, they have accepted. Okay, please raise the hand or reply if you have got all these four correct for Q. Q all four correct. Huh? You do all this correct? Okay, you have already put the answer angular linear sp3 and 180 degrees. You put the answers horizontally, no? Tetrahedral angular sp3q. Okay. Tetrahedral angular sp3 bond angle. Okay, runs in correct. Please put the answer vertically, column wise. Then it's easy for me to refer. Okay. What about R? Sishan gave the answer trigonal plane angular. Trigonal plane angular. Okay. No. Electron pair geometry, Sishan, not trigonal plane. For R. Electron pair geometry tetrahedral because there's a lone pair. Electron pair geometry means including the lone pair. It's tetrahedral. Do you understand? R tetrahedral. Electron pair geometry. I mean just tetra. R. What is the shape means what? SHAP, yeah. Shape means what? It's molecular geometry. Within bracket right here is molecular geometry. Molecular geometry. Molecular geometry. And second one, Ransiluni, okay, I think Ransiluni posted the answer, no? Ransiluni gave. Ransiluni, can you quickly post the answer for the R tetra? Yeah, okay, go. You have put the pyramid long, very good, yeah, very good, pyramidal. Then next one, what is the hybridization of R? Ransiluni? Very good, yeah, sp3, I told you that earlier also. What is the angle? What is the bond angle of R? A bond angle around R. With a lone pair, what happened? It's like ammonia. Consider about ammonia, it's range. If you write 107 perfectly, okay. Between 106 to 108, they have accepted. I'll put here 107. 107 degrees. Huh? Then highlight this pink. Alright. Then T. Electron pair geometry, tetrahedral. Electron pair geometry, all three tetrahedral, because what matters for the electron pair geometry, remember electron pair geometry also what? 5 bonds are not considered. For both hybridization and electron pair geometry, 5 bonds are not considered. If you can add that to your short notebook. For both hybridization as well as for electron pair geometry as well as for the molecular shapes, molecular geometry, electron pair geometry as well as for the hybridization, 5 bonds are not considered. Write it with the red pen. Important. Right. Then what is the shape around this T? T is sulfur. What is the shape around sulfur? The molecular geometry. Yes? Can you quickly post the answer to chat? Very good. Yeah, it's tetrahedral. Very good. Tetrahedral. Answer is correct. Tetrahedral. And what is the hybridization of this? SP. What is hybridization? SP. SP hybridization. And the bond angle tetrahedral one around 109.5. But if you write 109, that's accepted. Between 108 to 110, they have accepted. Now tell me how many blanks correct out of 4 into 3, 12 blanks. Out of 12 blanks, how many blanks correct? Out of 12, how many blanks correct? Yes? How many correct? Yeah, it's SP. Sorry, it's SP3. Sorry. Yeah, it's SP3. Yeah, sorry. SP3, yeah, sorry, by mistake. It's a mistake. SP3, yeah, correct. Yeah, answer is correct. How many correct out of this? Only 4 out of 12 blanks. Correct. Zishan? Considering how many correct out of 12 blanks? Zishan, you found this difficult. Only 4 correctly out of 12. Ah, that's why. Okay. Okay, Ranasuni, okay. Maybe your most acceptable structure went wrong, then this will go wrong. Yeah. So that is very risky. Again, I am telling in the exam, even in the school term test papers, most acceptable structure, you have to double check before you write the answers for the rest of the parts. Okay, right. Okay, Sushant, right. Then part 5. Part 5 very easily. Hybrid orbitals in the formation of following bonds. QR, sorry, OR mean what is OR? It should be QR, no? This should be Q, sorry, this should be Q, not O. This is Q and this is O minus, O minus. Q and R, Q sp3, this is also sp3, very easily. Actually, all this sp3 because we have already predicted the hybridization. This is like kind of a stupid question asking again and again, because previous one they have asked the hybridization of each atom, then they asking. This is not a good question because it's like repetition of the previous one. sp3 we have already predicted, again they asking Q what is S. R also we have predicted. We again asking what is Q&R hybridization. To the hybridization correct. This O minus you can take 2p unhybrid orbital. This one you can take as 2p. Right, sorry about that. Right. Now this is sp3. I told the rest. No, this is sp3. Sorry, it's not this one. TO minus sp3 and 2p. sp3 and 2p unhybrid orbital. No, sp3 and 2p unhybrid orbital. Then part 6.1. Part 4.1. What information is directly provided by the Lewis structure of a covalent compound of iron? What information is not direct? This is a very good question. Put 3 stars. You can learn something about Lewis theory from this part for the answer. Can you guess? What is the white background to for the answer? Part 4.1. 4.1, what is the answer? Yes? What information is directly provided by a Lewis structure of a covalent compound? When you draw the Lewis structure, what informations you can get? You can get the total number of valence electrons. Distribution of valence electrons you can get. Distribution of valence electrons. Distribution of valence electrons. What else? What else? Can find charges on the atoms, you can decide, no? Charges on the atoms. Charges on the atoms. Instead of distribution of valence electrons, you can write number of, or you can write here, instead of first one, you can write number of lone pairs, number of bonding pairs. You can, by looking at the Lewis structure, you can tell the number of bonding pairs. By looking at the Lewis structure, you can tell the number of lone pairs. Number of lone pairs, you can tell. Number of bonding pairs, number of lone pairs. According to the Lewis theory, yeah, correct. Transferring charges on the atom, total number of bonding pairs, total number of lone pairs. Now tell me what informations cannot be provided by the Lewis structure. Part 2. What informations cannot be provided by the Lewis structure? Yes? Any idea? Okay, you gave here hybridization. Okay, answer is correct. Anything else, Sejan? Anything else? Now, okay, I'll tell one example. Can we decide the shape of the, will Lewis structure provide? When you are drawing the Lewis structure, do you consider the shape of the molecule? No. Okay, I'll give one example. If you draw, if you ask to draw the, okay, we look at, forget about the answer. If you ask to draw the Lewis structure of water molecule, if you ask to draw the Lewis structure of the water molecule, if someone draw like this, okay, Lewis structure of water molecule. Lewis structure of water molecule, H2O. Lewis structure of water, when you draw, you can draw like this. Is this wrong? Is this correct or wrong? Lewis structure of water molecule. If you want, you can draw this way also. Which one is correct? Now imagine in the exam you get, okay, I will give a very simple one. Draw the Lewis structure of the water molecule. You draw, one student is drawing the first one and the other student is drawing second one. Which one is correct, or will you give full marks for both? Will you give full marks for both the students? Huh? Or the second one is more correct than the first one, and second is, oh, first one is wrong, second one, what do you think? Yeah, yeah, correct, Sanjay. Both are correct. Both are correct. Seshan, both these correct. Why? Lewis structure does not describe or explain the shape of the molecules or bond angles or shape. I mean, Even hybridization. When you are drawing the Lewis structure, we don't need to mark hybridization. We don't need to draw the shape of the molecule. We don't need to mark the bond angles. That is not provided by the Lewis structure. If you draw the Lewis structure of the water molecule, it does not provide bond angle. Otherwise, then there will be every Lewis structure, the most acceptable one, you will have to mark the bond angle in. Unless they ask, we don't mark it. Unless they ask, we don't mark it. Therefore, Lewis structure, the shape of the molecule, not considered when drawing the Lewis structure. Very important. Right here, the shape of the molecule, the shape around central atom. The shape around central atom. Then the other information not provided by the Lewis structure is hybridization. Hybridization. Third information not provided by the Lewis structure will be bond angles. Actually, it's a Lewis theory introduced by G.N. Lewis. Lewis theory. And the next information not provided by the Lewis structure will be orbitals involved in the bond formation. Oxidation number also not provided. Oxidation number, valency, not provided by the Lewis structure. Valency, lot of things not provided by the Lewis structure. 1, 2, 3, 4, 5, then 6th one I'll write. Orbitals overlap when forming the bonds. Orbitals involved when forming bonds. Orbitals involved when forming bonds. For the formation of bond formation. For bond formation. Please copy down this. Are you still writing this or shall I erase? Please raise the hand if you are still writing this. Information is not proper. Now, why do you need to copy down all this? Sometimes in upcoming papers, this structured essay can become MCQ. In upcoming papers, this structured essay can become a MCQ. Huh? The structured essay can become MCQ. Is that clear? Any questions? Shall I erase this? Anyone will copy it out? No. Right? Okay. I'll erase this. Then next one. Part C. State whether the following statement are true or false. Give reasons. Decreasing of the error. Whether it's true or false and with reasons. Decrease in order of electronegativity. Decrease in order of electronegativity. Ammonia, then NO2F, and then NO4 3 minus. So first you have to mention whether it's true or false. Plus you have to mention whether it's the reason for that. Reasons, if it is true, why the reason. If it is false, then give reasons for your choice. Yeah. First tell me whether it's true or false. Electronegativity depends on what? Electronegativity of nitrogen. Yeah. Electronegativity of who? Nitrogen. Electronegativity of which atom? Nitrogen atom. Electronegativity of the nitrogen atom. Nitrogen electronegativity. So the best thing is what? You can electronegativity right here. Electronegativity depends on the oxidation number, hybridization, charge, S character, and okay, let's try this. I'll give the answer like this. What? Please write here. When the oxidation number increases, electronegativity increase. Right here. When the oxidation number increases, electronegativity increase. When oxidation number increases, electronegativity increase. When the positive charge on the atom increase, electronegativity increase. Higher the positive charge. Fact, okay, please write a short note on this. Then it's very important because it's important for the upcoming ones. Factors affecting the electronegativity. Please write this, everyone. Factors affecting electronegativity. Right. Number one. First factor, right? Oxidation number. Oxidation number. When oxidation number increases, electronegativity increase. Right here, when oxidation number increases, electronegativity goes up. I put En, electronegativity increases. Number two, second factor, right? Number two. Positive charge on the atom. That means electropositive. When the positive charge increases, electronegativity increases. Second point. Third one. Third one, right? Ansiruni, maybe you can't hear clearly. Maybe I think Srishan, you have the same problem. Can you hear me, both of you? Maybe your side the internet connection unstable. Srishan, can you hear me clearly? Okay. Ansiruni, your internet connection must be unstable. Can you hear me, Ansiruni? Anyway, you can request the recording after the class if you have if you experience in any internet unstable internet connection, right? Number three. Third one. Third factor that affect the electronegativity, right? Hybridization. When the hybridization runs, can you see the screen at least? So in case of hybridization, when S character increases, hybridization what happened? When S character increases, electronegativity increase. Example you can write here, sp hybridization, what is the S character? 50%. sp2 hybridization, what is the S character? 33.33. In sp3 hybridization, what is the S character? S character will be 25%. So out of 4, like sp3, there are 4 orbitals. Right? So therefore, please, this last one is very important. Higher the S character, higher the electronegativity. Higher the S character, higher the electronegativity. So therefore, sp hybridized orbital, higher S character. S character will be 50%. So I put S here. S means S character. So if you take one example, again I'll put example for this. If you take C2H2, C2H2. So this carbon will be what the hybridization sp. Therefore this is more electronegative than that carbon will be more electronegative than C2H4. C2H4, what is the S character? 33.33. This one 50%. So here the hybridization of this carbon will be what? sp2. So sp2. So this is sp2. sp2. Therefore that one is less electronegative. If you take so that now you can understand alkane and alkene and alkyne. So hybrid both carbon atom. Electronegativity of carbon is 2.5, but this electronegativity depends on the other factors also. Pauling scale is 2.5, but this carbon atom is more electronegative than the other carbon because of higher S character. Please copy down this note. It's like a short note for you. Is that clear? Right. Then next one. What are the factors affecting? Oxidation number. Higher the oxidation number, higher the electronegativity. Number 2, positive charge. Higher the positive charge, higher the electronegativity. Number 3, hybridization. When the hybridization, the S character goes up, electronegativity increase. Please write it. Write it. And the charge. I told charge means positive charge. Yeah. Charge, oxidation number, hybridization. So those are the 3 main factors that will affect the electronegativity. Right. Shall I erase this? Anyone still copying down? Are you still writing? Or when you're done? Are you done? Okay. I'll erase this. If not, tell me. I'll display again. Now let's see the answer for this. Now we'll write the S character. What is this called? N2O. All 3 will decide this. NO2F. NO4 3 minus. And NH3, let's see. And in NH3, let's see the oxidation number. Okay, first I'll write the oxidation number, then you can easily compare. Oxidation number. This NO2F, what is the oxidation number? +1. You have to give this explanation, otherwise if you just write, first you have to tell this is true, it is true. Now we are writing the reason for this. +1. This is also plus, this is +5, sorry about that. It's +5, NO2F +5, not +1. This is also +5, no? And the third one is -3. This oxidation number will be -3. Oxidation number -3. Oxidation number -3. Second one, number 2. Number 2, charge. Charge on nitrogen. Charge on nitrogen. What is the charge here? NO2F, what is the charge? +1. Charge on nitrogen. Is +1. Yes, 0. When you draw the Lewis structure, you get a +1 charge on nitrogen. That's what it means. Plus charge on nitrogen and the oxidation number, 2 things. When you draw the Lewis structure, you get a plus charge on nitrogen. That's what it means. Third one. By considering all this, then hybridization. Let's see the hybridization. Hybridization. What is the hybridization? Hybridization. What is the hybridization of this nitrogen? sp2. You have to draw the Lewis structure. You have to draw this structure to decide this. If you want, I'll draw this structure also. It's simple molecule. You can write this. sp2. This is sp3. Which one has higher S character? sp2, no? sp3, the S character will be 33.33. Now you can easily guess it. Oxidation number I give, charge on nitrogen I give. So you get by considering all three, which one has the highest electronegativity, this nitrogen, because electronegativity highest NO2F, that nitrogen, that the given node is correct. Thus plus 5 both become more significant here, plus 5 and plus 1, and sp2. This is the most important thing. Both the first two factors both same for NO2F and this one, but sp2 matters here. This one what matters when you compare 2 and 3, oxidation number also matters, and the charge also matters, and this also matters. All three matters here. First two, when you compare, the hybridization matters, because the others same. Hybridization matters for the first two. When the hybridization, this is what is the S character. S character out of, so there are three orbitals. S character will be, contribution from S will be nearly 33.3% out of 100. So here the S character contribution from the out of all four orbitals, there are four orbitals involved in the hybridization, 3 of p orbital and 1 from s orbital. So 1 s orbital and 3 p orbital. Contribution from s will be what, 25%, no? 75% from p character, 70 sp3 p character 75%, right? S character will be 25%. Is that clear? If you take sp hybridized orbital, S character 50% contribution from this, and P character 50%. So what matters, when the S character goes up, electronegativity increase. Is that clear, my explanation? Is that clear? Did you get it? Why this is important? Not only for this one, upcoming papers, they can give this under MCQs. They can give which of the following factor will affect the electronegativity. They can give MCQ, the statement questions, which of the following factor will affect the electronegativity. Or sometimes they can give again this and ask which one has the highest electronegativity out of the following. So this past structure this can become upcoming papers MCQs. That's why. Okay, then Sijan, are you okay? Shall I erase this? Right. Then next one. The last one, part 2. Increase in order of, not melting point, melting point. This should be melting point, no? Increase in order of the melting point of lithium halides. Lithium halides. This should be LiF. F is missing here. Right. Lithium fluoride, lithium chloride, lithium bromide, lithium iodide. Okay, what are the factors? Now this is melting point. Melting point highest Li, lithium iodide or lithium fluoride. Is this false or true? First tell me, previous and true. This one is false. Why false? Why false? Melting, all these are ionic. All these are ionic. Electronegativity difference, highest electronegativity difference, LiF. Ionic character highest, LiF. Therefore melting point highest, LiF. Put an arrow. Lithium fluoride has highest electronegativity difference, highest En difference, and then lowest. When electronegativity difference highest, ionic character highest. Please write it. Ionic character highest. Highest ionic character, highest electronegativity difference, LiF. Highest ionic character, LiF. Highest ionic character. Third one, highest melting point. Therefore the melting point become highest. So lithium iodide will be the lowest. Both these lowest. Lithium iodide, it's lowest. lowest electronegative difference and lowest ionic character, LII, lowest, both lowest. But if someone write the explanation this way also is accepted. Okay, answer sir, when we write reasons, should we write them as paras or point-wise? Better to write point-wise. Don't ever write long paragraph in the science paper. If you are doing English literature, history and the other subject, you might write paragraph, write point form. Point form. Point form, it's better. It's easy for the marking examiner. It's like this. For marking papers, they are paid. Marking examiners, for marking, they are paid. If you are writing unnecessary lot of stuff, right, you write long paragraph. So but actually the marking scheme only 2 words the answer. Marking scheme only 2 words the answer, but to find these 2 words they have to read long paragraph, half page paragraph. Even after reading this half page paragraph, those 2 words are not there. Then what happened? It's waste of their time, and sometimes your handwriting also problem, like all this matters. Therefore if you don't know, please leave it. Don't write lies, right? Most probable answer, if you are not sure, you can write the most probable, but don't write everything that you know, especially science. I mean, in a subject like science, means like biology, chemistry, physics, all three. Biology to a certain extent that accepted. Biology also point form, I'm not sure, but our time is point form. So don't ever write paragraph, right? Write in point form. It's better to write in point form, right? If you want, you can write like paragraph also through 2-3 sentences, but that's not bad. But make sure you keep the active words or the technical terms. Even though you know the answer is in your head, but it is not reflected in your written answer. What you thought, not reflected in the in the written answer, then also you don't get marks. Sometimes you might, if you ask to explain, then you will explain this nicely, but that is communication problem, verbal, and kind of it's like what you thought, you should be able to reflect that to the O level or A level or any other national exam in Sri Lanka. It's written paper, no, they evaluate, right? Not by looking at your face, not from an interview. Sometimes what happened, the person who has written this one and got 9s, the other skills nil, right? Presentation skills nil, eye contact nil, other skills not good. You understand what I'm saying? That's why some doctors no patients, some lawyers no patient, no customers, no clients. Therefore those skills come from the school, right? So this is just the subject knowledge. That's why anyway you have to your answer should reflect that you know this well. I mean, you write exactly the point without writing the other rubbish. Anyway, so that's why the point form, no problem. Even if you write a paragraph, no problem. But the other problem is, structure is you're not going to give an additional papers. Sometimes what happens, you write with the resonance structures with the pen, and you know that you have your most acceptable structure also wrong. Then what happens? You can't, Tipex not allowed. You can't erase it. And then what happens? You cut with one line, then you put an arrow and write somewhere here. That also not good. Right? Therefore, if you are not sure, you write with pencil in a rough paper the answer. And after that, you transfer this to the letter if you are not sure. Or else you write in one corner, you write everywhere, and here that clear no space. So at least draw this structure. If you're not sure, draw this corner, and if you have a problem, you can draw this corner, at least the rest. After cut this with one line. And the other most important is, some students, they, if you ask yes or no, you write both yes and no. Then what happens? Then they have the right to evaluate only the first one. Then the first bird that was there. You write increase in order and decrease in order. You write both. Increase in order also you write, decrease in order. I mean, all the possibilities you give, then they have the right to mark only the first one. Okay, those things. So that's all this paper. If you want, you can write using the polarizability of an ion. Also you can write polarizability highest. Please write that. This also you can add instead of these 2 points for the explanation. You can write polarizability highest iodide ion, because I minus electron cloud, I minus is large, that electron cloud can be easily attracted towards whom? Towards the positively charged lithium ion. You understand what I say? This electron cloud is not symmetrical because of Li plus. Li plus can attract iodine electron cloud much easily than fluoride F minus. Why? Because I minus, the electron cloud is larger, it's loosely attracted to the nucleus of iodine, therefore it can be easily attracted toward this Li plus. Therefore polarizability has I minus. Therefore covalency, then when there's a polarizability, covalent character is more covalent character, when covalent character increase, electronegativity melting point decrease. More covalent character with the anion with highest polarizability, more covalent character, because ionic ones, in ionic compound they are just ionic spheres, plus and minus, like minus like this. But if it is ionic, but if it is covalent, what happened? This electron cloud, positively charged cation, will attract the anion electron cloud. Then it has some covalent properties also, like this here. This is pure ionic, this is pure ionic, this is what ionic, but it has some covalent character also because of the pulling of the electron cloud of the anion by the cation. So that is called the polarizability of the cation, polarizing power of the cation. Anion we call it polarizability, cation we call it polarizing power. Cation, small cation has higher polarizing power. Please write it. A small cation has higher polarizing power. That means what? Li plus polarizing power is higher than K plus. A small cation can pull the electron cloud more strongly. Polarizability has large anion. Again I am telling you, large anion and small cation. Large anion and small cation, more covalent character. Please write it. Larger the anion and smaller the cation. What increase? Covalent character increase. Best example, lithium iodide. Lithium iodide higher, lithium iodide, this covalent character increase not due to the cation, because all this lithium iodide, lithium chloride, lithium bromide, lithium fluoride. So lithium is common to everything. Then what matters here? Size of the anion. Larger the anion, higher the polarizability and higher the covalent character. Is that clear? Or if you want me to repeat again, tell me. This is very important. Put 3 stars for the last part. It's introduced to new syllabus. Before 2011 they have not put this in the, yeah. Right. Okay, then that is the end of this paper, and I have posted 2017 and 16 also. I'll discuss that in the next class. I'll put a cover up lesson in January. This is 17 and 18. Sorry, 16 and 17 I'll discuss next day. 16 and 17 I'll discuss the next day. And next class falls on first Wednesday. Come on, we miss one class in December. I'll put that in January, one of the holiday, public holiday. Wednesday, 5th of Wednesday, right? Next class, 5th Wednesday, January, right? 2022. So then we stop for today. Wish all happy new year, and next class will be held on 5th of January. God bless you.